They finally opened the moon, and what scientists found inside changes everything. After decades of mystery and countless scientific hypotheses, we finally have a clear understanding of what lies beneath the surface and deep inside the moon. Scientists have officially resolved a long-standing mystery about the moon's internal structure, confirming that its inner core is not molten, but a solid sphere with a density akin to iron. This groundbreaking discovery sharpens our understanding of the moon's geologic past and offers new perspectives on the evolution of its magnetic field, an element key to deciphering the moon's early activity and its broader role in the solar system's history. Building a lunar map from Earth. To uncover what lies at the heart of the moon, a research team of the French National Center for Scientific Research didn't rely on seismic data alone. Although Apollo mission instruments provided valuable lunar seismic records, their resolution wasn't precise enough to confirm the state of the moon's inner core. Instead, they integrated data from space missions and lunar laser ranging experiments. Their approach was designed to measure how the moon deforms under Earth's gravitational pull, how its distance from Earth subtly shifts, and how its density profile compares to known materials. Overturned deep in the lunar mantle, the simulations also uncovered signs of active overturning deep within the lunar mantle. This process involves denser materials sinking toward the moon's center while lighter ones rise toward the surface, a mechanism that may help explain the elemental anomalies found in volcanic lunar regions. According to the team's results, the moon's core consists of an outer fluid shell surrounding a solid inner core, similar to Earth's internal structure. The fluid outer core is estimated to have a radius of about 330 kilometers, while the solid inner core spans roughly 240 kilometers, comprising approximately 15% of the moon's total radius. The inner core's density, calculated at around 7,822 kilograms per cubic meter, closely mirrors that of solid iron, providing compelling evidence that the moon's internal dynamics may not differ significantly from those of Earth, confirming old clues with modern techniques. This isn't the first time scientists have stumbled across hints of a solid lunar core. In 2011, a team led by Renee Weber of NASA Marshall Space Flight Center used advanced seismological techniques on Apollo data to arrive at similar conclusions. They proposed a solid core radius of about 240 kilometers and a density nearing 8,000 kilograms per cubic meter. Understanding the moon's core matters for more than just internal cartography. The moon once possessed a strong magnetic field, which began to decay roughly 2 billion years ago, since such fields are driven by core motion and convection. With renewed efforts to send humans back to the moon, researchers are hopeful that future missions will include next-generation seismic instruments. These could offer direct confirmation of what advanced modeling already strongly suggests. The moon has a solid, iron-rich inner core,